Welcome everyone to this introductory video on thin layer chromatography, also known as TLC. Throughout this video, you'll learn what TLC is, its importance, and how it is conducted. The purpose of TLC is to separate mixtures and also identify unknown ingredients in drug compounds. This can be very beneficial for many industries that require a high standard of product quality and the need to monitor for contaminants. These industries include food chemistry, pharmaceutical production, and more. This method is also more advantageous compared to other analytical methods because it is relatively cheaper and faster to conduct, which results in a higher throughput. However, TLC is only used for initial screening of compounds and is usually used in hand with another analytical method to confirm the compounds of interest. Due to these characteristics, it is diversely used in larger-scale surveillance programs. TLC is not a complex technique to understand and conduct, but there are a lot of different factors that can affect the effectiveness of TLC. To start, we will discuss the equipment needed to conduct TLC. Shown here is the setup of what a TLC experiment would look like. First, we have a plate, which is usually a thin glass plate coated with silica gel and is considered the stationary phase. The solvent is considered the mobile phase, because it will be moving up the plate through capillary action. The mobile phase will usually be a mixture of different solvents in order to create the right polarity, which is a factor we will discuss later. These spots are the samples of interest and will move up the plate alongside the mobile phase. It is important to note that very little amounts of samples are needed, which can be added under the pros of using TLC. Lastly, some sort of container or jar will be used to contain everything in it. Now that we have all the equipment we need, we can discuss the steps for successfully carrying out TLC. Step number 1. Measure the starting point for the spots on the plate. This is done by simply drawing a straight line across the silica gel plate. It is important that this line is higher than the level of the mobile phase solution in the container to accurately measure how much the spot traveled. Step number 2. Next, we need to prepare the samples. The samples can be compounds in solid or liquid form. Since very little sample is required, we will need to dilute it before spotting it onto the plate. We can dilute it in any volatile solvent that the compounds are soluble in. And using the rule of thumb for dilution, which is a ratio of 1 to 50 to 100, where for every 1 milliliter of sample, you would add 50 to 100 milliliter of the solvent. The reason for this dilution is that if you spot a pure compound onto the TLC plate, the spot will start to streak as it moves up the plate because there are too many compounds. Step number 3. After preparation, we can start to spot the TLC plate. We will first take a bit of the sample by using a capillary spotter and then gently pressing each sample along the drawn line. You should notice a small circle of sample being added onto the plate. The spots should be away from the edge to prevent the compounds from streaking on them. Step number 4. After spotting, you can now place your mobile phase in the container, and then place your plate in the container after this. Let it develop for a couple of minutes, and make sure that the level of the mobile phase moving up the plate remains parallel to the straight pencil line. Once the mobile phase reaches 1 centimeter from the top of the plate, take it out of the container and immediately trace a line across the mobile phase. Step number 5. Finally, because most of the compounds will be organic, we will be visualizing the plate by shining UV light over the plate. Organic compounds tend to be colorless, and the silica gel plate will fluoresce under UV light. This fluorescence will be blocked by the organic compounds and show up as dark spots. While these pictures are shown as black dots, in reality, they may be too difficult to see with the human eye, which is why we have the help of the UV light to visualize the spots for us. Now that we have the experiment set up, let's talk about the factors that influence the results and how to understand them. In this technique, we follow the solubility rule. Like dissolves like. This rule means that compounds with alike properties will enjoy being with each other more. The silica gel plate is highly polar, and the mobile phase is less polar, and the compounds will have varying unknown polarities. This is how we get our compound separation from the mixtures, where the compound with lower polarity will move further up the plate as it has a preference for being in the mobile phase, and vice versa for the compound with higher polarity. This is why our mobile phase will be made up of various solvents, as we would have to determine the best polarity to optimize the separation of compounds on the plate. Now, how do we actually go about identifying the compounds? Retention factors. That probably doesn't make sense, nor does it sound exciting, but it is a crucial component to TLC. The retention factor, or RF, is used to quantify the distance that each compound in a mixture travels. It is simply quantified as the ratio of the distance traveled by the spot or solute to the distance traveled by the solvent. The RF factor should remain the same for each compound over multiple experiments, given that the conditions are the same, which is how TLC can be used to identify unknown compounds. You can start to understand now the use of TLC and how important it is to the identification of unknown compounds. Despite TLC having many advantages, there are some limitations that come along with it. The first major limitation is that TLC is unable to identify new compounds. This is because an RF value must be known beforehand to identify the compound. Another limitation is that another analytical method is usually done alongside TLC, mass spectrometry, for example, because it is not accurate enough on its own to conclude the final compound. Despite this, it is important to note that a newer version of TLC has recently been developed, high-powered TLC, which has higher throughput, higher accuracy, and is automated. To recap, we covered why TLC is used, the equipment and steps for a TLC experiment, factors that influence the results, and the limitations of TLC. That covers all the basics of TLC, and I hope you learned something new. Thank you for watching.